Hi everyone, in this video I want to talk about factoring polynomial expressions with a common factor. These are the two problems that we'll do, and to make sure that we don't take ourselves too seriously, let's think about the fun question: what household chore is your least favorite? Okay, so this topic falls under Algebra I. Technically we are factoring something out of a polynomial. So what's the largest factor that would be able to come out is the question that we will ask ourselves in these two problems. Okay, so in the first one we just have one variable, second one we have three. So let's think first about what a factor even is. So I am looking for something to take out of these four terms. And that something is going to be a factor that is common among all four of those terms. So just to recap, a factor, let's say of, we'll list all the factors of 24. That's 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, so those numbers multiply to one another to get 24 as a product. A multiple is just 24 times 1 times 2 times 3 times 4. Okay, so think of number of hours in 1 day, 2 days, 3 days, and so on. Okay, so the factors of 24, this is the full list. Factors of, or multiples of 24 goes on to infinity. Okay, those are infinite. So what I'm trying to figure out is what is a common factor, actually the greatest common factor, that can come out of 48, 16, 72, and 16. Let's just talk about that. We'll talk about variables next. Well, we have the use of a calculator, okay, if you need it. There is actually a GCF feature on the TI-83 or 4. So we're racking our brains, we're thinking about our times tables, and yes, 2 works. Yes, 4 works, but we want the greatest common factor, the biggest thing that can come out, and that is an 8. But all 4 of these terms have x's, and if you imagine this 7, x to the 7th, as literally 7 x's, and then 5 x's and 3 x's and 2 x's, think about what is the biggest number of x's that can come out of all 4 of those terms. The greatest number of x's that is common among all 4 of those is 2 x's. We can only take 2 out of all 4 of those. And then we just have to think about what's left over in parentheses, meaning how can we basically divide this 48x to the 7th by 8x squared. Okay, so the number that's missing here is a 6. And then the number of x's would be 5, because if we remember exponent rules, x squared times, say, x to the 4th is x to the 6th. We add the x's. We add the exponents, meaning like if we had 2 x's here, 4 x's there, that's a total of 6 x's, which is why we end up adding as we multiply 2 terms with the same base and different exponent. Okay, so now this is going to be minus, and 8 times what is 16? 2. How many x's? 3. 2 plus 3 is 5. Then what's left here? 8 times what is 72? 9. How many x's? 1. And then, okay, our x squareds match here, so we don't need any sort of an x term, but we just need a constant number, which is 2 for this one. Then going forward, I see none of this has a common factor that can come out of all 4 terms. So I can tell that that is my final answer right there. Then over here, this just looks like a mess, but what we have to figure out is the common factor with all 4 numbers, coefficients, as well as common factor with all of the variables. Okay. So I'm scanning those 4 numbers and I'm thinking, well, they're all even, so 2 for sure can come out. But then I do have to check and make sure that nothing higher can come out. So then all of a sudden I think 4, but 4 does not go into 18. And then 6 would not work in everything. 8 would definitely not work in everything. So let's just call it 2. Now we have to decide how many x's, y's, and z's are common among all 4 terms. So if I think of this as like 2x's, 1x, 2x's, and 1x, the greatest number of x's I can pull out of everything, all 4 terms, is just 1x. And then the greatest number of y's I could pull out is 2y's. The greatest number of z's I could pull out of all 4 terms that is common is 1z. Meaning I couldn't take, let's say, 2 z's out because there's only 1 right there. You can't take 2 z's out of 1 z. So you always have to go for the lowest exponent amongst all of the terms that you're comparing. Okay, so now this is -5, and then, okay, how many x's, y's, and z's are left over? Okay, x times what is x squared? X times x is x squared. And then y squared times what is y to the 5th? Remember, we add the exponents in this case, so it's 3y's. We need 3y's to end up getting 5y's. And then the z's match. So I do z to the nothing. There is no z there. And let me just speed up a little bit. So then this one will be 10. How many x's do I need? 0. How many y's do I need? 1. How many z's do I need? 1. And then 9, I need 1x, I need no y's, and I need 1z, minus 4, and then I need no x's, I need no y's, and I just need 1z. So imagine yourself then distributing this in your mind later, and you should be getting the answer above. I can tell nothing is common. I can't pull a common anything out. It looks like a z I could, but then there's no z here, so this is fully simplified. So that must be the answer. All right, time for some practice. These are a little easier than the ones I just gave you. Just think of what the GCF would be, greatest common factor. Why don't you pause the video if you would like to see the answers? Okay, answers are there. First one only has 1 variable. Second one has 3 different ones to think about. Lastly, we have a quote. Keep it going. This is from Bob Ross, legend. Talent is pursued interest. Anything that you're willing to practice, you can do. It's great for ACT prep, and it really makes me think about talent. His talent is probably, just practice from the past. So if you guys would like to keep up with videos, I'd appreciate if you subscribed. I also would like to see what your least favorite chores are, because I'm wondering if they're the same as mine. If you would like to comment, that would be great. And I hope this video helped you. Have a great day.